Hello everyone, I am Giovanni Adragan. Our topic for today is all about potentiometry. So in our objectives, define potentiometry, discuss the principles, functions, and type of potentiometry, and also how to operate the instruments and how to read the results and the importance in the pharmaceutical field. So what is potentiometry? It is defined as the branch of electrochemistry, which focuses on the studying and measuring electrode potentials. The measurement of the electrode potentials is widely used in the field of pharmacy, specifically and potentiometry titration. So in the chemistry analysis, it is the way measuring the potential between the two electrodes while controlling the electric current. Two types of electrodes are employed in the most popular techniques of potentiometry. So the two electrodes is indicator and reference electrode. Sila yung nagme-measure. So next, we have the types of potentiometry. So first, we have the acid-base titrations. Second, we have the complexometric titration, and third, redox titration. And lastly, precipitation titrations. So first, let's talk about the acid-base titration. Titration of hydrochloric acid with sodium hydroxide is the way is can be done by potentiometric titration. This concentration of the given acid base is determined by using a standard solution. So it's the way of determining how the much acid base is present in the solution and also determining the volume of acid or base that will completely react with it. So next, we have the complexometric titration. In this type of potentiometric titration, concentration of metal ions are determined in the analyte. In this membrane, electrodes are used. So at titrant based on the formation of or coordination complexes between a metal ion and complexing agent or chelating agent to form soluble complexes. Next, we have the redox titration. This type of potentiometric titration involves an analyte and titrant that undergo a redox reaction. An example of this type of titration would be the treatment of an iodine solution with a reducing agent which produces iodide ions. A starch indicator is used to get the endpoint. So a redox titration is a titration in which the analyte and titrant react through an reduction reaction, as in acid-base titrations. The endpoint of the redox titrations is often detected using an indicator. So next. So we have the precipitation titration. In this type of titration, the precipitate is formed as the name suggests. When the addition of titrant no longer forms a precipitate, the endpoint is noted as the endpoint. So in this type of titration, the combination of two ions reacts of analyte and titrant result in formation of very insoluble precipitates. So which precipitates are formed. So next, let's move on to function of potentiometry. Potentiometry, one type of electrometric method, is used to determine the concentration of a solute in solution. In potentiometrics measurement, the potential between two electrodes is measured using a high impedance voltmeter. Two types of potentiometric sensors are available for environmental applications: glass electrodes and solid state electrodes. So kaya yun nga is to determine the concentration of the solution Kaya ang two electrodes, yun ang nagme-measure which is the reference and indicator electrodes. So next we have the principles of potentiometry. When the pair of electrodes are placed in the sample solution or analyte, in shows the potential difference between the two electrodes by the addition of the titrant or by the change in the concentration of ions. So we have two electrodes which are the reference and electrode and indicator electrode. The two electrodes that are mentioned are named reference electrode and indicator electrodes. The reference electrode is the electrode that maintains its potential and remains stable when dipped into a sample solution. An indicator electrode is an electrode that responds to variation in the potential of analyte solution. A salt bridge is used to prevent interference and of the analyte with the reference electrode. So for indicator electrode showing a response in the change of solutions, and also the reference electrode is to maintain or stable lang siya ang stable lang ang sample. So next, we have the electromotive force or overall potential difference can be calculated by using this formula. So we have E cell is equals to E indicator E minus 2 E reference plus E1. So where E cell is electromotive force of the complete cell and E indicator is what electromotive force of indicator electrode and E electron in and E reference is electromotive force of the reference electrode and E1 is electromotive force at the junction across the salt bridge. So next, the importance of potentiometry. So we have first, in clinical chemistry, it is used in clinical chemistry for the analysis of metals. So ion selective potentiometry is used more and more in clinical medicine for the determination of electrolytes in variation body fluids. So yung electrolytes ay mga minerals sa body natin na may electric charge. So next, we have the environmental chemistry. It is used for the analysis of yanay, ammonia, etc., and water or wastewater. They use potentiometry in the monitoring of environmentally important trace metals and anions and natural water and soils. They can easily know the toxic effect of the metals on aquatic biota, which can also affect the health of people consuming seawater foods. So next, the general method for potentiometry. Switch on the instrument, connect the saturated calomel electrode to the positive terminal or socket and the glass electrodes to the negative, and arrange the calomel electrode and the paddle of the stirrer in such a way that it must be at the lower level of the glass electrode which is placed between them. Adjust the meter to zero and standardize this electrode system as above, as subsequent readings are to be taken with the stirrer motor running. The next, rinse the breaker and extract thoroughly with water, then with the solution to be titrated, and place a measured volume in the breaker and add sufficient water to cover the bulb and of the glass. Electrode adequately and switch on the stirrer and measure the pH of the solution, and also add about 2 ml of titrant, allow sufficient time to mix and measure the pH of the solution and add further quantities of titrant. And as the endpoint is approached, reduce to 0.1 ml increments and measure the corresponding values of the pH. And then obtain further readings of pH for about 5 ml beyond the equivalent point and switch the method to standby and turn off the stirrer. Wash the beaker and electrodes thoroughly with the distilled water. Plot a graph of pH, titrant added, read of the equivalence point of the graph and calculate any required data from this value. And if the titration is of a weak acid against a base, calculate the pKa volume of the acid from the Featherstone equation, which is valid over the range of pH 4 to pH 10. So that's the end. Thank you.